Okay, so we saw that const comes in handy to protect changes, protect being made to parameter values or arguments that you supply to a function. And this can be for if you don't need to make any modifications inside functions to the things that are passed in, you protect the parameters with a const. It's a good idea to protect all parameters. So as much as possible, use const. And also for not just for standalone functions that we've done in the past, but also for any class member function. All the parameters in class member functions, as much as possible, try to make them all const. It's an extremely good idea. In Java, we try to make all parameters be final. That's always recommended. Not everybody does it, but it's always good to do that. Okay, so now let's move on to inline functions. Inline functions are nice for efficiency. What it means that if you have a function that's quote-unquote inlined, then when you call that function, all of the code for that function is actually inserted instead of making a function call. So here's the bottom line for inline functions. The code for that function will be put into the place where the call is made. What's the reason for this? The reason for this is the way hardware works. If you actually call something, you're jumping around very far away from where you started in memory. And so there's a huge overhead with doing this, mainly because hardware today is heavily pipelined. That is, you try to look at a whole bunch of instructions at a time. And if you have a lot of small functions that only, let's say, make a simple assignment, you want to inline them so that you take that code and put it directly into where you call it. This is a lot more efficient because of the way hardware works. And it works really, it works best when the function is short. If you have a super long function, you probably are making it less efficient, probably, I don't know, by making it inline. So if you have very small functions where you're just setting some value equals 5 or something, whatever, then it's tremendously more efficient to do inlining. Okay, so let's take a look at what inlining is. If you have non-member functions, just a function, standalone function outside a class, then you want to use the keyword inline in the function declaration and in the function heading. For a class member function, let's say you have a function inside a class, if you put the method body or the function body inside the class declaration, then, or I guess, yeah, class definition. So the way they use it, the class definition, then it's automatically inline. So let's take a quick look. Some code. We can just quickly scan something like this and say, okay, so if you don't have a method body, then unless you do something special, it's not inlined. So this is not inlined, this is not inlined. None of these are. How do we inline it? Let's say something like a getX function. All you do is you copy this method body, and you can get rid of this now, and you put it here. That's it. You don't need the semicolon, I guess. So now I'm confused. Let's try it without the semicolon. So it's always, oops, now I have to save this too. We have to save both of them, the xyz.h and .cpp, recompile, and everything works. Yeah, so you don't need the semicolon. And what I usually do is, since it's such a short function, I just put it all on one line. This doesn't make a difference. Putting it all on one line doesn't make a difference, but having the function body right in the class, I guess this is the definition. I was saying declaration, but no, this is the class declaration. Oh, sorry, this is the class definition, sorry. And now if you put the function definition in the same place as the function declaration, then you get inlining. If you put this in the .cpp file, so you take this and put it where it was over here, then you don't have inlining unless you specifically say inline. So something like that. Okay. You just check and make sure this works. Alright, so we got some kind of problem, but this is the kind of thing that you need to do. Maybe I have to fix that up. So by default, this is not inline, and I believe you can inline it by saying maybe, or maybe you can't, or maybe you have to have it in the class definition. Yeah, I guess it's not allowing us to do that either. Alright. Some very strange errors that I haven't seen before. So to be sure that you are inlining, I'm just going to say that you're going to have to put it right in the class definition. For sure, those things are inlined. So for class member functions, place the implementation, that is the code for the method or function body, inside the class definition. This is automatically inline. I think you should be able to inline the stuff that's in the .cpp file, but it's not. Apparently it's not working right now for me. Okay, inline member functions. Typically it's defined separately in a different file, can be defined in class definition. And so if you put it inside the class definition, it makes the function inline. This is, although you can inline anything, it's only really, it only makes a difference in efficiency for very short functions. So you can inline anything, but probably shouldn't. If it is too long, it's actually, it says here it's less efficient. For one thing, it makes your code bigger, because every time you call a function, and that if that function is massive, your code becomes massive, because you replace the code for your inline function into wherever it's called. So in that way, I guess it is less efficient, but time-wise, it might not be so bad. Lastly, let's take a look at a couple of other things. We look at static data members, static member variables, and static member functions. And then finally, we'll end, I think, with vector. So static member variables are also in Java, and it's the same idea. All objects of that class share one copy of the variable. So the classic example that I look at is, let's say you have an account class and you have a minimum balance, which is going to be the same for all instances of that account class. So what you want to do is you want to make sure that it's all the same for all instances. You make it static. So if you have a data member, it's going to be have the same value for all instances of the class. In the case of the account objects, the thing that's going to be different about each object is, let's say, the current balance. Let's say you have one person, Joe, has $100 and Mary has $500. And let's say the minimum balance is $100. That minimum balance is going to be true for Joe and for Mary. And so you want the minimum balance to be a static data member. And I don't know if you guys remember, the non-static data members are called instance data members for Java. It's pretty much the same thing for C++. Okay, so if you make something static, all you have to use the static keyword, and all objects of that class share one copy. It actually is one physical memory location for all objects of that class. So it's also space efficient. So if you change it somewhere, and if one object changes that variable, then all see the change. So typically you want to make it const, probably, like you would make it final in Java. This is useful for tracking. Let's say you do make it a variable, you do not make it const. Let's say you can find out how often a function is called by incrementing a value inside that function. So number of calls, ++, and that can be static. or you can put that number of objects and make it a number of objects and increment it each time every constructor is called. You can find out how many objects of that type exist at any time. Okay, so as with Java, just put the keyword static. You can have, like in Java, you can have functions that are static. And remember, the same rules apply. Static functions can only access static data members. So static methods in Java can only access static data members. That's the rule in Java, that's the rule in C++. So if you do not need access to instance data members or object data, but you still want the function to be a member of the class, make it a static function. So this is really just saying, you can make anything static, but keep in mind that you only have access to static data members and not to instance data members. You can, if you make things static, like all the math functions in Java, like math.pow, math.square root, those were all static functions, and you can call them outside the class. The same thing in C++. And here what you use is not the dot notation. You use the class name, and you use the scope resolution operator, but you can also call it using the dot notation. So if you have an object, that is, if you don't have an object, then you want to use this notation. You want to use the scope resolution operator with the class name, scope resolution operator, and method. If you do have an object, you can use the usual way of saying object name dot static function. In Java, it used to be that this was no problem, that you could always do this. For static functions, you could not do this, but more recently, in the last few years, the compiler will warn you and tell you this is not the way to use a static function. Use the class name. So it's sort of a mix in Java. In Java, you do not use object names, or you can, but you should probably, it'll warn you and say that you should use the class name. So you can think of this as Java as having the sort of best of both worlds. It doesn't need this extra operator like we do in C++. Bottom line, calling a static function, probably best to use, say, class name dot dot static function name. And remember, you can only use, a static function can only use other static functions and static data, just like in Java. And there's this nice example in here. This is display 7.6 from chapter 7. You want to go through this. I'm going to skip it because it's basically just because it's the same as in Java. Okay, just like we have Java util vector, there is actually a vector class in C++. And the nice thing about this is that just like in Java, these vectors are actually arrays that grow and shrink, just like in Java. Java does the same thing, and you can just keep adding things. This is from the standard template library, which we will look into more detail later. And it also uses templates, which is generics. Same idea as in Java. The idea of Java generics came from templates in C++. So it's very similar to array. It has a base type. So you can only store things of a base type. So for example, you can store things of type int. So this is the base type for this v vector. It's a vector of type int. Now this is different from Java. In Java, you could not have generics with primitive data types. You could only use classes. In C++, it's different. You can use classes, but you can also use primitive data types. Okay, so I'm not going to go into this into a whole lot of detail. Definitely take a look at this. Apart from slight syntax differences, lowercase v and so on, essentially the same idea. To add things, you have to use a member function called pushback. I know it's kind of odd, but that's how it works. So then there's a nice example. Definitely look at how this example works. It'll show you how to use vector.